Uranium. Uranium is one of the most essential elements in modern history because of its role in developing nuclear weapons and energy. Its primary isotope, or a variation of the element, is uranium-238. Uranium may be found on Earth and is expected in the planet's crust, but uranium extraction is tightly regulated due to its different effects. Because of its association with nuclear weapons, it is one of the most volatile elements on the planet, making it arguably one of the most dangerous elements. While uranium is helpful for nuclear reactors, which provide energy to different parts of the planet, radioactive waste disposal is one of the biggest environmental concerns. Disposing of nuclear waste improperly can have adverse environmental effects. Thorium. Named after the Norse god of thunder, thorium could be one of the essential elements for the future of science and technology, especially in the nuclear field. It's not the same material used for Thor's hammer. Still, this radioactive element could be a better alternative to uranium as an energy source because thorium doesn't undergo nuclear fission when an atom's nucleus or core splits into two. Instead, its isotope, thorium-232, is a fertile element that can absorb a neutron, a particle found in the nucleus of an atom, and turn into uranium-233, which can be used in nuclear reactors. Thorium's stability is why researchers believe it can be a better element for nuclear reactors. Stable elements are less likely to cause nuclear accidents, making them a contender for a more sustainable energy source that minimizes environmental concerns. However, the biggest challenge is that the methods used to extract thorium are more expensive than those used to extract uranium. The nuclear applications of thorium are also still being studied, but if thorium's practical uses are proven to be safer and better than those of other radioactive elements, it may be able to solve the world's quest for a cleaner and more reliable energy source. Potassium. Potassium has a radioactive isotope known as potassium-40, which is less radioactive than other radioactive elements, but still contributes to the natural radiation in the environment. It is an essential element for living beings and helpful for different applications. Potassium-40 is used for radiometric dating, which calculates the age of natural Earth-based materials by measuring the presence of a radioactive element. Geologists can estimate the age of rocks and fossils by measuring the ratio of potassium-40 to argon-40, another radioactive element, making this element helpful in understanding the planet's evolution. Due to its low radioactivity, potassium doesn't have the industrial applications other radioactive elements have. Still, it is one of the safest radioactive elements and has helped advance geology and other similar scientific fields. But it's not always the safest element out there. When used in the form of potassium chloride, it can be lethal and is one of the 3 drugs used for lethal injections in the US. Carbon. Carbon is the fundamental element of all organic compounds on Earth. Its radioactive isotope is carbon-14, formed in the atmosphere when exposed to space particles known as cosmic rays. Carbon-14's presence in the atmosphere allows it to be absorbed by living organisms when it is incorporated into carbon dioxide and is absorbed by plants. It's then incorporated into plant fibers through photosynthesis, the process by which plants use sunlight as their energy source. Due to its availability in organic substances, carbon-14 is also widely used in radiometric dating. Living organisms absorb carbon-14, which allows scientists to estimate the age of organic materials using the presence of this radioactive element. That's why carbon-14 is one of the most essential elements in archaeology. Carbon-14 contributes to the planet's natural radioactivity, but is a mildly radioactive element that poses little to no risk to living organisms. Because of its applications in archaeology, it has contributed to our understanding of history. Radon. Radon is a noble gas with a radioactive isotope known as radon-222, formed in the Earth's crust through the decay of uranium and thorium. As such, it is a byproduct of 2 highly radioactive elements, making it moderately radioactive and quite dangerous. The biggest concern about the safety risks involved with radon is that it can accumulate in homes, buildings, and other enclosed spaces. As a colorless and odorless gas, radon is undetectable to human senses. So when it reaches high concentrations in enclosed spaces, increased indoor radiation exposure can lead to diseases, such as lung cancer. It is estimated that as high as 14% of lung cancer cases in the world can be attributed to radon exposure. That is why ventilation is essential in enclosed spaces, as radon can accumulate and pose health risks. Polonium. Polonium was discovered by Marie and Pierre Curie and was named after Marie's home country, Poland. In 2006, it made headlines all over the world when it was found that a former Russian citizen named Alexander Litvinenko died due to polonium poisoning. Polonium's high radioactivity is why it can be a dangerous metal. Polonium, however, is a rare element with few industrial uses. For example, it's one of the elements used to initiate nuclear reactions. In the past, it was used to detonate the earliest versions of the nuclear bomb. Besides that, it has limited practical and noble applications, making it one of the more useless radioactive elements. Handling polonium also requires caution and special equipment due to its hazardous nature. Moreover, it is extremely dangerous when used for malicious purposes, even when it isn't used to detonate bombs. Radium. Marie Curie and Pierre Curie were responsible for discovering radium in 1898. It's an alkaline earth metal that is moderately radioactive. Radium's most common isotope is radium-226, which can decay further to produce the more stable lead-206. The decay process of radium-226 was used for early versions of glow-in-the-dark paints, as it allows radium to emit light. However, an advanced understanding of radioactive elements made it clear that exposure to radium was dangerous, especially if ingested or inhaled. That's why it is no longer used for glow-in-the-dark paints and clock dials, as it can potentially cause bone cancer due to how it bonds with bone tissues. Technetium. Technetium is the first radioactive element with no stable isotopes, which means that all of its isotopes are radioactive. Technetium-99m is the most helpful isotope of this element because it can be used for medical applications, specifically single photon emission computed tomography, or SPECT, an imaging procedure that views how blood flows through arteries and veins in the brain. Technetium-99m is used for medical purposes because of its short half-life, which is the time it takes for the element to reduce to half its original value. Elements with shorter half-lives minimize patients' radiation exposure. However, technetium's lack of stable isotopes and rarity limit its industrial applications. Its help in revolutionizing nuclear medicine is one reason this element is widely accepted in healthcare, as it minimizes potential health hazards. Promethium. Promethium is one of the 24 known elements that don't occur naturally on Earth, making it synthetic. This radioactive element has no stable isotopes, with promethium-145 being used in nuclear reactors. However, promethium has limited applications. One of the most notable applications of this element is using self-lighting signs, because the decay process that promethium undergoes allows it to produce visible light. It can also be used for atomic batteries in spacecraft because of the energy that its heat and radiation produce. However, due to its high radioactivity, promethium requires strict regulations in handling and disposal. Moreover, its use should be controlled because it can lead to severe health and environmental risks when misused. Americium. Americium is a synthetic transuranic element created by bombarding plutonium with neutrons, or an uncharged particle, in a nuclear reactor. Its isotope, americium-241, is used in smoke detectors because it emits particles that allow it to trigger the alarm in smoke detectors. Despite the low supply of americium, its effectiveness in fire safety measures and minimal risk make it one of the most notable radioactive elements. Its short half-life also minimizes its dangerous and radioactive elements when exposed to humans. However, strict measures remain to dispose of americium smoke detectors. Americium has few other industrial or practical applications outside of fire safety. However, due to its high energy output, it can be used for spacecraft batteries in the future, making it an intriguing element for scientists to study. Californium. The transuranic element Californium's most stable isotope, Californium-252, can emit neutrons, giving it a high potential in many fields of science and technology. Californium-252 can be used in neutron radiography to obtain detailed images of materials and structures in scientific research. It can be used in medicine for cancer treatment, where tumor cells are bombarded with neutrons to force nuclear reactions. However, californium is limited, making it difficult for scientists and researchers to take advantage of its medicinal, industrial, and scientific versatility. It is also intensely radioactive, making it hazardous when mishandled. It was discovered in the University of Berkeley, thus explaining why it was named after the state of California. Tridium, hydrogen-3. Tridium is an isotope of hydrogen, also called hydrogen-3. While it may be radioactive, it has found many practical uses because of its relatively short half-life and the minimal risks involved with its use. In most cases, tritium is used for exit signs and watches because it has a self-luminous property, meaning it can produce light independently without an external power source. However, it can also be used for applications as big as nuclear weapons and reactors. When weaponized, it can boost the power of nuclear explosions. But when used as an experimental power source, it helps nuclear reactors generate more energy. Iodine-131. Iodine-131 is an isotope of iodine with an unstable nucleus, giving it its radioactive properties. While it may be radioactive, it is widely used in medicine due to its versatile properties, especially in nuclear medicine. This element can manage hyperthyroidism, a condition that occurs when the thyroid gland produces too many thyroid hormones responsible for regulating the body's metabolism and development. Due to the radiation it emits, it can also be used to treat thyroid cancer. However, iodine-131 can also be used for industrial purposes, especially in radiography, or sterilizing or cleaning different materials. When used in radiography, it can detect problems in industrial materials used for buildings. Iodine-131 has versatile uses and minimal health and environmental dangers, making it one of the most valuable radioactive elements. Cesium-137. Cesium-137 is an isotope that has found purpose while acting as a dual-edged sword due to its usefulness and potential environmental risks. Regarding its industrial applications, it can be used for gauges that measure the thickness and density of different materials, such as paper and soil. But while it may be helpful, it has been detected in areas affected by nuclear testing and accidents, such as the Chernobyl disaster. Its long half-life also makes it dangerous to the health, especially in long exposures. Cesium is also so reactive that it can eat through glass. This is why careful management is necessary when using cesium-137, as it can potentially lead to health problems for industrial workers exposed to its radiation. Industries that often handle this element should also address proper disposal to avoid a similar incident to Chernobyl.